On construction oversight, in general, the inspection verification comes into three phases. Pre-construction, reviews, critical, construction, and then verification, repair, and final permit. So you can organize, depending on your jurisdiction, might be a little different than this, but you can organize your inspection verification around that. Pre-construction reviews, I think this is probably your most important step. You can avoid a lot of problems getting everybody in the room together. Setting the guidelines, expectations, timing for inspections. Construction sequencing, checklists, determine training needs. So just as an example of the importance of pre-construction meetings, checklists and plans. Years ago, we built a low-impact development pilot project, and one of the stormwater requirements was that all of the lots, because they were entirely disturbed, they were very small, 3,500, 4,000 square foot lots, had to be compost amended, BMP T513, which you have to do now. By the way, that's just a blanket requirement now. Those guidelines were in the landscaping section of the plans. Did the folks doing the utilities, stormwater, all that, look in the landscaping plans? And so at the end of the project, comes to, oh, by the way, when are we going to get the soils, the compost spread and till it in and do the compost amendment? And the developer says, what? What compost amending? Because they were not accustomed to looking in a landscaping section of the plans for stormwater requirements. So that's a great example of how important it is to get everybody on the same page. Where is everything? Where are all the requirements? Are we all clear on what we're doing? What you're responsible for, and what's the timing of that? Pre-construction thing is absolutely critical. Well, there's 2, 3, maybe 4 missing on this list purposely. What would be one group you would want in pre-construction reviews that might be really important? Has to do with road widths. Fire and safety. There's a really important one to have in the room, up front. In fact, earlier than this, in the initial design considerations, to make sure you're meeting, all fire and safety requirements. Fire and safety is getting more used to seeing this stuff, but 10 years ago, fire and safety was a major barrier to the implementation of low-impact development, because there was a lot of talk about reducing road widths, right? And fire and safety was, wait a minute, my stuff's getting bigger, and now you're telling me we're going to have smaller roads? And so there was a lot of saber rattling around that. I think that's kind of settled down a bit, but that's a very important group to have in the room up front, very early on in design. First site visit, pre-bioretention soil media placement. So here's at least a partial list of things you want to consider. And I'll mention at this point, I think Seattle now has some pretty good construction checklists that are available and use if you'd like. You want it, very important, certified native existing soils are comparable to design consideration, temporary erosion and sediment control in place. Rough grading to plans, under drains and overflow, field changes. How are you going to deal with that? Are you going to accept photo documentation of certain phases of the project? That's a question you have to ask up front. Why would rough grading and final grading be critical for a distributed stormwater management system? So you've got more complex flow paths. You've gone from thinking about one big giant contributing area to what? Small contributing areas. Your grading's got to be, should be, it's got to be right. Otherwise you might have contributing areas that are much bigger or different than what you anticipated. So, a little bit more, pretty important to pay attention there. Second visit, this is before the bioretention media goes in. Now we've placed the bioretention media, and you want to, again, run through some checks, verify that the bioretention soil media meets the composition guidelines and depth. Probably not that long ago, when you accepted materials off the truck, whether it was topsoil, whatever it might be, you might have accepted a truck ticket. And I remember many years ago, there were projects. I've been involved in projects where, they talked about we're going to verify the media with a truck ticket. I think those days are, as Chris says, are in the rear view mirror. You need to be more precise about that. And there are a lot of suppliers, well, not a lot, but there are suppliers out there now, and those suppliers should provide you with verification of that material that's delivered. We still have material coming onto sites that are not meeting specifications. Project in Seattle, they had to remove, I don't remember how many hundreds of cubic yards of media, and Seattle brought a container of the material for me to look at and potentially test, and we didn't have to test it. It was obvious. It was probably, they probably flipped it. It was probably 60% compost and 40% sand. And so it was just, you could tell right away, too rich in organic material, and it clogged immediately. So this still happens. And so you have to verify that that material is meeting spec, and so there should be verification of material that's being delivered, not material that was tested a year ago or 2 years ago or whatever. Okay, so this is pretty important. As I mentioned there, you can see truck ticket crossed out. Visual, textural, no way. Current lab report from a physical submittal. That's what you want to work off of. Truck ticket, no way. That visual, textural should be crossed out as well. Unless you're a soil scientist that's worked with bioretention media for the past 10 years, you are not going to be able to tell a 60-40 from a 40-60. It's very difficult for visual, textual inspection. Compost, however, if you have compost delivered and you're mixing some, there's visual and textural and smell that most people can catch on to quite quickly. But determining if bioretention media meets a specification from visual is very, very, very difficult. Question is, perhaps in the future, a requirement for a soil scientist to verify this stuff? So far, I only have experience with a couple of suppliers, Cedar Grove and Walrath, and they're both quite responsible. They seem like they're quite diligent as far as meeting the meeting guideline and supplying that verification. So that probably would be enough, but you never know, especially as we get into other kinds of media. Post-construction, verifying your final grade, again, important for contributing areas and that you have proper flow paths. All of that is in place. Contributing area, designed properly and stabilized, verifying that the media is not clogged, and infiltration rate adequate. Okay, so this is an interesting one. So what we've been finding in a lot of the media we've been testing is much higher infiltration rates than what's currently prescribed. Really what you're generally only going to be concerned with is if it's clogged and it's not draining. On the flip side of the coin, if it's draining too rapidly, and I was talking to a designer earlier about some problems where downslope cells were not getting any water, because the thing sounds like the media is draining quite rapidly. There's also that consideration. There might not be as much a tendency to replace media if it's draining too rapidly as opposed to clogged. The message I'm trying to deliver here is that media is variable. Generally, we've been seeing higher infiltration rates than what is prescribed, often quite a bit more, 50, 60, 80, 100 inches per hour. I would say, as far as assessing your media and is it draining properly, to everybody take a deep breath and realize there's variability and that is the system working properly, and not necessarily focus too much on, wow, is it 12 inches per hour? It's got to be 12 inches per hour as a max. That's what I designed, and this is what it's going to be, it needs to be, or 6 or 8 or whatever it is. Realize there's a lot of variability here, and is the system working okay? And just don't get too spun up about a number, one number for bioretention media, because there's a lot of variability. Nevertheless, if it's clogged, you've got a problem, and you got to deal with that. Ponding depths, obviously, and verify your plants and mulch, and then you're good to go for wrapping it up. Generally, this is a range that I've worked with and that other jurisdictions have mentioned, 30, 45 day to follow up and remove your temporary erosion sediment control and to wrap everything up. There might be some steps that you're taking that are longer than that for establishment. You might be doing some things to allow plant establishment in these systems that might go on for longer than that. And now, element 13, you're going to have an O&M plan in place. That's a requirement. I want to show you a couple scenarios. So we're going to use a pilot project down in Pierce County as an example. It's construction sequencing. So this is critical. This is all part of your construction planning. What's the order we're going to build this stuff? Here's an example, a picture of a site that's flat or slightly sloping away from the bioretention area. And as you can see, the roads are done, the apron for the driveways are in, and some of the landscaping's in, but none of the houses are in yet. In this case, this is a relatively simple scenario as far as construction sequencing and protection of your bioretention area. So you're probably going to be able to get away very adequately with relatively conventional approach. Silt fencing, you might want an additional wattle or berm built up around that silt fencing. The biggest concern here is going to be compaction and intrusion into the bioretention area in these small lots. Really actually advised is robust fencing around this. And you're going to have to keep people out of there. And humans are genetically predisposed to throw things in holes. You know it's going to be used for some construction debris. So how do you keep people out of there? Well, silt fence and proper installation of that silt fence and perhaps some additional protection might be fine for sediment because the grade's not steep into the bioretention area. It's actually sloped away a little bit. But really keeping people out of there is the big deal. So this is relatively easy, pretty straightforward. This is not. So this is right across the street. This is a more difficult scenario. So now you have these small lots sloping to the bioretention area. Construction's going on in the winter. Bioretention areas are complete, pretty much. Landscaping's not in, mulch isn't in, but essentially complete. You've got a problem. It's almost the worst case scenario that you would probably ever face for installing bioretention. What are we going to do in this case where we've got a construction activity sloping to the bioretention area? I'll tell you what the solution was right now with that site. They bermed up the edge of that bioretention area about 3 or 4 inches. Obviously totally inadequate. Okay, any ideas of what you might do all the way back to construction planning? I mean, that's fair game, how you'd plan this thing out. In this case, you really have a kind of a major division. Are you going to divert the flows around the facility and treat them somewhere else? Bill is talking about, are you going to put it through, a Baker system or into another pond, a settling pond or whatever? Maybe that gets pumped out, whatever it might be. Actually, in this case, we didn't have that option. It couldn't be done with the road configuration. Unless you did collect it in one place, which was very difficult, and then put it in a pipe or something and moved it around. So we found that on this particular site, it was very difficult to bypass and deal with the construction flow some other way. But you want to be thinking about that. Can we do it? And how do we do it? In this case, it was very difficult just because of the configuration of the project. So we were stuck with water flowing into these systems during the home construction. If you're facing that scenario, and this is really worst case, facing that scenario, what might you do? Try to stabilize upslope areas. Again, in this case, it was really difficult because, well, one, they're continuing construction in winter, and the lots are 3,500 square feet. Almost all of the lot was being built on. So it was difficult to do that, but that's another important consideration. Stabilize the ups gradient. That's a great way forward, and the point was you could line the facility and allow the flows in, which had to be done here. And then, once you're done and deal with those flows, however it might be, you might pump, you might direct those flows downstream to a central temporary pond that's either pumped or you're treating the water somehow, whatever it might be, and allow water through these things. So, but you're protecting it with a liner. There's some other possibilities too. That's a really good one. That would probably be up at the top of the list. So the other point is, okay, you allow flows in there and then come back and clean it up when the homes are done and you're stabilized. That's another really good possibility. So that scenario would be a little different though. And what that would mean is, probably the best way to approach that is not put in your bioretention media, partial grade, down to 6, 10, whatever it might be, at least a minimum of 6 inches above your final grade. So rough them in. You might put down filter fabric, you might line them, you might put down some mulch that you would remove, allow those flows through there, treat them how you decide to treat them. When you're all stabilized, remove that material down to final grade. So you've got a filter layer on top. And that's comprised of, could be, again, various things, but certainly you're not at final subgrade. You're above final subgrade, finish, come in and get to final grade, put in your media, plant them, and finish up. That's another approach here. There's a significant issue around that though. This gets back to construction planning. Everybody's got to be clear. That scenario requires that everybody knows what's going on. You have to know, obviously, the engineer, the developer, and the people building the homes have to know what that construction sequencing, how that's going to work. So for example, on this project, sort of a debrief with the home builder. In this case, there was one home builder. That was the one thing that made this project not absolute worst case scenario. There was one home builder instead of 30. In this case, in a debrief with the home builder, I asked him, I said, well, hey, what if we had done this? What if we had, roughed out the facility, put protection around it so you couldn't compact it and blah, blah, this, that, and the other. And then you come in and once the homes are done and you're putting in landscaping, you come in and finish the final grade, put in the media, finish these things. And the home builder actually said, I would have preferred that. That can work. It's just critical here is that everybody needs to be on the same page. You have to make sure this works for the jurisdiction. There's some jurisdictions that are going to strongly discourage you from allowing any construction flows into bioretention areas. But having said that, there might be cases like this, like the one I just showed you, where there's very few options. There's not much other option. And then you sit down and come up with a good plan moving forward. And you make sure everybody's on the same page and everybody understands how we're moving forward with this. So for sediment, we just talked about this. There are ways to deal with sediment that's relatively easy to deal with. The little bit of research around this, studies and monitoring around this is that if 6-inch typical native soil provides a very good filter for sediment, so you can protect a facility if you leave it proud, 6 inches. And if there's sedimentation to the media or the mulch, and certainly before you plant, it's pretty easy to remove that mulch and scrape off some media until you get to a point the engineer says you're good to go. We're all good to go. As far as sediment. Compaction's a different story. And the first question you want to ask, does the facility still infiltrate? Whether it's the subgrade or the media. So before you say, oh, we got to tear out all the media because you've been in there with some machinery or whatever, take a deep breath. Does the facility still work? Do some tests and then move forward. Subgrade compaction is your toughest scenario. If it's wet and it's been compacted by heavy machinery, you might have compaction down 2 to 3 feet. Depends on the soil type, depends on the machinery, how wet the soil is, but that's what you really want to work to not allow compaction in these facilities. The media gets compacted, that's a relatively easier scenario. You might have to remove the media, but that's fairly easy compared to deep subgrade compaction. And I would say that for preventing compaction, I'll reiterate that usually silt fence is not enough. If you really have a tight building scenario, you're going to probably need to put up some robust fencing to keep people out of that. I've got lots of horror story pictures of silt fence that's just flat on the ground, and the bioretention area is full of sheetrock, and there are outriggers in it and all that. So you need more than silt fence. Probably more than that orange fence too, in some cases.